So the question of this tutorial is, what does it mean to link Sparqlycode? Well, Sparqlycode is an application of the W3C semantic web recommendations for a data format known as the Resource Description Framework and its query language, Sparql. You can find out more about those technologies in many places, but in particular you can start here at the W3C's data activity website, Building the Web of Data. One of the quotes on this page I think is quite pertinent to us, there it is, thought I'd lost it, is this comment here on the page: the primary value of linked data of RDF and related technologies is that these technologies have the web at their core, providing a unique means of integrating data at web scale. I think this is important because when we're showing Sparqlycode, we're looking at very sort of small, kind of human comprehensible examples. But the fundamental point about why I thought the technologies were appropriate for this kind of problem, the problem of managing software, its configuration, its deployment, is that in reality we are moving to the point where large software portfolios are at web scale, and they are incredibly difficult to manage with conventional people-based processes. So the seed that we're planting with Sparqlycode is that ability to allow us to deal with software at web scale. So just to make the point again, we've used this unique means to enable us to allow software code, its configuration and its deployment environment to be linked, queried and reasoned over automatically. Essentially, this linking concept involves applying universal resource identifiers, or URIs as they're known, and if you peruse the W3C site on this technology, you'll find URIs are an important aspect of it. So what we're doing is, when we're looking at the software source code and other artifacts involved with it, we are producing unique identifiers for things and then associating important information with those identifiers. Now, software itself lends itself very well to the use of URIs because of its implicit need to uniquely identify code concepts for the compilation process. So Sparqlycode extends this principle to apply URI as broadly as possible to all artifacts in the software development lifecycle and its operating environment. So let's look at a contrived example. Putting these examples together is quite difficult and takes some thought, but hopefully if we asked ourselves the question for a web application, what code in my web project are dependent on code in Tomcat, for example. So that's what we're going to use as our example. Again, if you were starting from scratch, you might have your own web application. You've generated Sparqlycode from that using the SCE product, or SCE, Sparqlycode engine, and possibly you've acquired the Sparqlycode for the version of Tomcat that you are deploying to. Okay, so you would then end up with two Sparqlycode data files. In this case, I'm using Matt Rabel's sort of popular Maven archetype app views as the example web application, and we have a Tomcat Sparqlycode file here, both TTL files, turtle files in the RDF lingo, and the versions that currently don't matter. The implications of versions will be in a topic of a subsequent tutorial, right? But effectively, what we want to do is query these two files. Okay, as I said, one is our web project and one's Tomcat. And then there's going to be a Sparkle query that specifies the two Sparqlycode files as named graphs. So let's have a quick look at the query. Immediately looks a bit complicated, but this is the area that you need to look at in the query. So effectively what's happening in the query is that we're specifying these two files as named graphs. Now they can be referred to in the query, and the results from queries against each graph can then be combined in the context of the whole Sparkle query itself. So the first half of the query here, what it's doing, it's finding arguments for all methods on classes in the AppFuse project. What we want to know is which of the arguments are of types in the Tomcat code. For example, those with some experience of Java web development would expect to see instances of HTTP servlet request. Now the question mark underbar argument type variable will contain the universal identifier, again the URI, for this particular argument. Okay, so the second query, or second part of the query, sorry, is then moving on to include the Sparqlycode for the Tomcat code base. Okay, so the second query uses the URI for the argument types here, so it's inheriting that from the previous part of the query to match types that exist in the Tomcat code. To make the query more interesting, we've added a pattern to check that Tomcat Sparqlycode does actually have information about the methods for the class. So this is not necessary. Of course, this would be a skeleton query that you would build out and acquire more information about the Tomcat code anyway. But this bit is not absolutely necessary to prove the point, but I thought I'd add it here to make it slightly more interesting. So what we're doing is saying, well, okay, so if we find that particular type in the Tomcat source code, let's see if we can find the methods on it, ignoring whether it's an interface or a class at the moment, or an enum. And then what we're saying is, well, if a method does exist, then let's make the assumption that if method information is owned by this particular graph, then we can assume that it's an authority for that part of the code. So I've coined this term Tomcat owned, and we're just using a technique in Sparkle here to test if something is actually existing or not, and then bind, in this case, a Boolean attribute to that variable, which we can use on the projection in a query. So what I'll quickly do is just edit this query, because I've noticed there's something there that I would not want to show you just yet. I want to show you that at the end. So what we're able to do then is, here's the ARQ command, part of the Apache Jenna project. The query itself actually already specifies the files. So Sparkle, the query itself is telling ARQ which kind of files to open. So in previous examples I did specify the files on the ARQ command line, but that's not necessary when you specify files in the query itself. So if we run that query, it dawdles for a little while because there's quite a bit of code that it's meandering through, but then we end up with a report. Let's go to the top. There's a limit again on this query, just to always emphasize having limits on your queries. But you can immediately see that in our code base we've identified we have a class called baseForm controller. It has a method init binder. It looks like it has a number of versions of this method here. It accepts or has an argument that it calls the request, and it is the popular HTTP servlet request. The point I'll make in this particular view is that as we move to the last two columns of the report, we're now looking at results that we got from the Tomcat Sparqlycode TTL file, and this label, or the name, the Tomcat type name, is being pulled from the Tomcat Sparqlycode, and then we've got the column here that is just indicating true, that it's Tomcat owned. In other words, when the URI moved from the AppFuse part of the query to the Tomcat part of the query, it did find some methods for that particular subject. Okay, so it's just saying true. And if we go through, it seems like it's consistent. I don't know whether there's duplication coming back in this query, but you can see that we've got a save error, which also depends on the request, also a HTTP servlet request. Then we've got a save message. We can see that there's different types being matched as well. The other popular type is a servlet context on a set servlet context method, and we can just scroll through and see others as well. Okay, all different types. Okay, so what I've demonstrated here is linking two different Sparqlycode data sources. Just the very last thing to show would be to change the view to include a URI. Not as easily readable when you demonstrate the output, but it will make it clear that the thing that's joining the two bits of data together, not very easily readable, apologise for that, but you should just be able to see here, if I stretch the view, this is the URI for the argument that was discovered in the AppFuse software and passed through to the the AppFuse Sparqlycode and passed through to the Tomcat Sparqlycode. They're obviously both sharing references to a unique identifier. Okay, so where to next? I think we're still scratching the surface of what is possible with Sparqlycode. So really what we should do is possibly move to demonstrating that we're not just limited to querying the Java code itself, and that you can, in the same paradigm, start to join and interrogate other types of information. So I think the next tutorial would be based on the question, what other types of information are queryable?
For further information on Sparqlycode, visit our webpage at www.sparqlycode.com, or connect with us on Twitter @Sparqlycode, or email us on info@sparqlycode.com. For expertise on semantic web technology in general, visit our webpage at www.intuition.net.